Welcome to another video. Let's solve another functional equation. This one is slightly different from the previous one we did because the previous one had an explicit definition of what f did to the original input. We just had to find when the input is x. But in this case, there's no explicit definition of what f does to whatever input you have, so even a substitution will not take us to our straight answer. And I remember the first time I saw this problem, I solved it within 1 or 2 minutes. So I told myself, okay, I know how to solve it. When I get home, I'm going to write down what I did in my head. But I got home, it has taken me 2 to 3 days, and I cannot find that simple, straightforward method I used. I had to devise another way to get the answer. Now, I know in the comment section, someone is going to tell me what I was supposed to do. Please leave your comment in the comment section. Let's get into the video. There are many strategies that you can employ in solving a functional equation. The easiest of them usually comes when they've already given you like a function on the right hand side, not a recursive function like this one that depends on what happened before. So I said, I don't know what to do with this, so I'm just going to plug in numbers. Or let's make this simpler. Let's simplify the right hand side. So we can say that f of x plus 1 equals, I'm going to write it as x plus 1 plus 1, so I can get what I have here also on the right hand side. So I write it as f of x plus 1 plus 1 plus 1. Okay, so what I have here now is this is here. Okay, so I can easily say if this is the input, then this side is the input plus 1, right? So I can say, therefore, f of x, let's say the input was x, then this side is going to be f of x plus 1 plus 1. Okay, now this is what I would have done if I did a t substitution. If I say, let t be x plus 1, we'll end up with f of t equals f of t plus 1 plus 1. And then I'm going to switch back to x. But it looks like I should just stay with x, okay? That's better, okay? So, but really, I still need to have an answer to my problem because it is still recursive. It still depends on x, but I don't want it to depend on f of x. I don't want it to depend on f of x plus 1. I just want it to be f of x equals something on the right-hand side, a function that you can equate to 0 and solve for x. Okay? But I don't see it. So what I'm going to do at this point is try to plug in some very smart numbers. Let's start with 0. I want this to be 0. So I can say, by observation, when x is equal to 0, then f of 0 will be equal to, this is 0 plus 1, so it's going to be f of 1 plus 1. Okay, I see that. Let's try another one. When x is equal to 1, then I have f of 1 will be equal to f of 2 plus 1. Do you see what's going on? It looks like this is 0, 1, 1. 1, 2, 1. This 1 is consistent. It's a constant. Let's try one more number. Let's try negative 1. So I'm going to make this negative 1. So I have f of negative 1 will be equal to, if I put negative 1 here, it's going to be negative 1 plus 1. That's going to be equal to f of 0. Okay, f of 0 plus 1. Okay. I'm trying to see if there's a way I can make things work. So f of 0 equals f of 1 plus 1. There is this consistency you can see that when you increase this by 1, you just need to add 1 and then both of them will be the same. The way things are going, it is beginning to look like a linear relationship. Okay, that's what I'm thinking. Now, if you're solving this for a math competition, what you want to do is try all the possibilities. And the first possibility I tried after I forgot the first trick that I used the first time was to go back and say this level of consistency in these three terms. So I'm going to try something. Let me assume, okay, I'm going to assume that f of x is just a multiple of x. That is, what comes out of x is just going to be a multiple of x. Okay? That's something you'd need to try if this was an Olympiad problem you were solving. It's one of the strategies. Now, what you should do is go here to the original, to this one, and say, let f of x be equal to k of x. We don't know if it is true, but if it is true, we're going to get an answer. If it is not true, we're not going to get an answer. Okay, so f of x equals k of x, but this has been defined as f of x plus 1 plus 1. So what we're saying is a multiple, a scalar multiple of x will be f of x plus 1 plus 1. But by that definition, it means f of x plus 1 has to follow this rule. We also know that f of x plus 1 will be equal to k times x plus 1. That is k is just multiplying the input. That's all. Okay? So what would f of x plus 1 be if we solve this? Well, this is going to be equal to kx plus k. So f of x plus 1 is kx plus k. F of x is kx, but it is f of x plus 1 plus 1. So it means we can take kx plus 1, plus k rather, and put it here. So we can say that this expression, kx, is equal to kx plus k plus 1. Okay? Oh, look. Kx is equal to kx. So if we strike these two out, what do you think is going to be left? You'll end up with, well, these two will cancel each other out if you subtract kx from both sides. And you have k, and you have 1. You can move this 1 here so that you end up with k equals minus 1. So we found an actual value of k. And that means what we're saying is if this assumption was true, well, it looks like it's true because we got an actual value for k, then f of x is minus 1 times x. We can say this means f of x is equal to negative x. What? Yes, that's the answer. Remember, it's a strategy you adopt if you've tried other things and nothing appears to be popping up. It doesn't make sense, but there's this level of consistency. You want to try this strategy. Make sure you pay attention to that. Now, f of x is negative x. Is this what x does to its input? Yes, because I tried it. Now go back. F of x plus 1 is supposed to be negative x plus 1. So let's just check. Let's check here. So check. So we have f of x plus 1 will be equal to negative x plus 1. That's what we're supposed to get if what we're saying is true. But we're saying it is the same thing as f of x plus 2 plus 1. Well, what is f of x plus 2 plus 1? Well, it's going to be negative x plus 2 plus 1. So let's see if this and this are the same. What do we get on top? Negative x minus x. Is it equal to negative x minus 2 plus 1? Sorry, this is minus 1. Well, negative x minus 1 equals negative x minus 1. Looks like it's true. It is always true. It doesn't matter what you do. If you try this one also, look, f of 0 is supposed to be negative 0, right? If we say this is true, f of 0 will be negative 0, but negative 0 is 0. So we should get f of 0 should be equal to 0. But it's also equal to f of 1 plus 1. What is f of 1? F of 1 is negative 1 plus 1, which is also 0. If you have another strategy, let me know in the comment section. Never stop learning. Those who stop learning, stop living. Bye-bye.